Another part of section 5 is inverse tangent functions. So remember tangent, if we graph tangent, we go from negative pi halves, right, because there's a vertical asymptote here, and to pi halves. And it does keep on going and just repeats itself a pi length, every pi length, right? But here we have, so we have those vertical asymptotes, and then we have at negative pi force, we're down at -1. At 0, we're at 0. And then at pi force, right, if we put down that finger, they're both the same. That middle finger, that they're both the same on the left and the right, so that equals 1. So that's a positive 1, so tangent is like this, right? So then when we switch this around, our y values came from our x's. 0, and then this would be, no, this should be quarter, and this is a negative quarter, and then down here would be a full negative half pi, just a negative half pi. Okay, and then our x is for the inverse, right? So this one's just tan x, y equals tan x, and this one is y equals inverse tangent of x. And so here, our x values are from our y values, -1 and 1. So remember, we were restricted, right? We're naturally restricted. We didn't have to restrict these because we have these vertical asymptotes on the sine and cosine. We did have to restrict the domain. Here, our domain is pretty much already restricted. That's why we have just less than and just less than. Okay. On the other twos, they were less than or equal to. But here we have vertical asymptotes. Okay, onward. So at negative pi force, we're at -1. At 0, we're at 0. And then at a quarter, we're at 1. Right, and then we can't go higher than this, right? So this is restricted here and restricted down here. So our graphs look like something like this. This one comes down and approaches that. So you notice on this one that here our y values are restricted. On the other ones, as we look at like cosine and stuff like that, our limit was more on our x's, on our domain of the inverse function. Here, our domain of the inverse is unrestricted, right? We continue to go to the left, continue to go negative, continue to go to the right. Just our y values on this inverse is restricted, where on the other ones, just our domain was restricted, right? So we're good there. Okay, so now we can go ahead and practice some problems here. Okay, so here is arctan of 1. So we're finding arctan of 1. So that means I'm looking for what finger do I put down where the right side of my left hand and the left side of my left hand is the same numbers. Well, that's at 45 degrees. So, and we could look back at that graph. That is root 2 over 2. That is 45 degrees. Or it'd be root 2 over 2 divided by root 2 over 2, right? That's what gets us 1, which is a 45 angle that produces that, or pi force. And that is between, right? That is between negative pi halves and pi halves, right? So that is our answer, either one of those two in radians or degrees. Now the secant one is a little bit different. So the secant one's a little bit different. And so here we can look at the inverse secant. So here's inverse cotangent, inverse secant, inverse cosecant. So the big thing here is inverse tangent, which is inverse cotangent is arccotangent, and that domain is from 0 to pi, which those are vertical asymptotes between here. Secant, inverse of secant, goes between 0 and pi, because we have, again, vertical asymptotes on that, but we also have a vertical asymptote at pi halves, right? So it also can't be pi halves. But it's between 0 and pi, but it can't be pi halves. And then cosecant is between negative pi halves and pi halves. Those were their answers range in between for these. So those are our domain. But going back to this example, so the inverse of secant is cosine, right? Cosine is 1 over secant. So that is cosine of a angle, right, is 1 over secant of an angle. But I'm going backwards right here. I'm finding the inverse. So really, I want to find cosine inverse of not, so this is not 1 over cosine inverse of 2, because I really can't get a cosine of 2, right? What I'm going to flip here, what I'm going to flip as a fraction is actually right here, the answer, right? The answer is going to flip. Okay, just like this, if cosine, say cosine is of theta is 3/4, that means 3/4 would equal 1 over 3/4. So see how my answer is the one that's going to flip to 4/3, right? My answer flips. So there's my answer. It flips in order to find the angle, right? So now I can go ahead and look at this. Okay, what an angle produces a 1/2 for cosine? Well, that is a 60-degree angle. So theta equals 60 degrees. Or you can put it in radians, which is pi thirds. Okay, so there is that. And then again, I guess if you need to, go ahead and pause this, and you could jot this down if you don't have it. Okay, so here's a couple more. Actually, not these ones, sorry. These are the ones. So here are your practice problems, number 37, number 45 on 684. So we're asking, what gives us what do we put down? That would give us a tangent of -1. What angle produces a tangent of -1? Well, that is a -1/4 pi. Right, so if you put that down, this one's kind of hard, but you basically, what gives you a +1, and it's a 1/4 pi or 45 degrees, but that would be a +1. If I want a -1, that means I need to drop below 45, so that's a -45 or a -pi, 1/4 pi. Okay, and then cosecant, that goes with sine, so I'm not going to flip the sine. I'm just going to do sine verse. I'm going to flip the answer, so that's a -1/2. So think about a +1/2. What gets us a +1/2? Well, a +1/2 would be a 30-degree angle, but I'm going to drop down, right? So I'm going to be -30, so a -30 degrees or pi/6. And so those are the answers for number 37 and number 45. Okay. And that's it for tangent and the reciprocals.